The title is basically how do you analyze your spend smartly so that you can achieve some savings. Means in a very layman terms, I have told that there are a lot of things going behind it, and it's specifically related to procurement. So I would like to ask, has any one of you worked in procurement before, or in fact supply chain at least? Automotive industry, pharmaceutical, semiconductor? No? Okay. So I think it's completely new for everyone. But my focus will be more on the AI side of it, not the domain part. Okay. So the AI side, basically, when I say, it's like till now how the procurement works, we will see that first, and then we will jump on to how we are utilizing the AI agents to segregate everything, and then basically how it is enhancing productivity or increasing, basically decreasing the time to achieve some savings. So let's get started. This is the agenda. Basically what we have is, we'll start with the introduction. We will see the background of the problem, then we will look into the actual problem statement, basically the solution what we are trying to build, then the methodology. So the solution architecture and methodology, I will swap continuously between these two slides. It's kind of related to each other. Fourth, we will see the results. What are the results which are available to us now within our organization? And if you see how drastically it is changing, if you use AI to analyze something, how drastically it increases your productivity. Then what are the next steps or improvement which we have planned for our application? Finally, ending with the acknowledgement and Q&A. So let's get started. So this is how procurement looks like. To be very specific, since I come from semiconductor organization, but it's not very restricted to semiconductor. For any procurement, this is your funnel. This is how it looks like. You purchase raw materials, okay? Then you basically you use raw materials, then you use them to build some products, okay? So multiple types of cost involved by the time you reach your final product, which you will sell in the market, okay? So you purchase raw materials, that's one type of cost. Then you have manufacturing facility. So you have to construct the manufacturing facility, construction cost, okay? You have to buy machines, again, one other type of cost, okay? So now coming to the overhead, now there are indirect expenses. I think indirect expenses are the expenses which are common across industries, not only manufacturing. Your janitor services. Even when you go to washroom, the tissues which you are using comes under indirect expenses for any industry, okay? So that's another type of cost which you have to manage. Basically, it's not like you can purchase from any vendor and then you are paying X amount. It's not like that. You have to negotiate for that also. Because when you go for shopping, you purchase one packet. When you are talking about an organizations, they package it in bulk and then purchase it, okay? So negotiation is at each and every step of the funnel. Fourth is market. So you have to analyze the market. Demand and supply analytics. Demand is very high, supply is very down, the prices of the product will increase, okay? Demand is basically almost, or you can say very less. You have the inventory, you have to write off the inventory to move forward, okay? Tomorrow next technology comes up, what you will do? You have to build. The last one is the final product, as I told. By the time you reach the final product, this is the procurement funnel. A very generic procurement funnel. It's not it's very specific to semiconductor, but yes. Now, if you see, each and every step has some spend involved. And when you scale it to an organization, consider a Fortune 500 organization doing this spend, it will be in billions of dollars. I'm not talking about INR, I'm talking about billions of dollars. Assume you spend X amount or X billions of dollars in a year, there are chances of negotiating with different types of supplier to save some amount, okay? Even if you save 10% of $1 billion, think about it, how much you will save, okay? That's a significant amount. When you talk about 10% of 1 billion, it's a significant amount. So let's see what's the problem statement we are solving. That was the problem statement, that was the background, why we are building such solution. So we are building a Cost360 solution for our organization. I didn't give my intro, but yeah, I work in Micron Technology, which is a leading supplier of memory products, NAND and DRAM. So people generally know more on the logical chips like the processor and all, but the memory is a major player. And nowadays, I think you must be hearing memory demand is like it's going very high because of the AI in data centers. So it is a one of the leading suppliers in the leading memory suppliers. So the product which I'm talking about, we named it Cost360. Why? Because we are combining all sort of spend. When I say combining doesn't mean just adding up or joining the data together. We are bringing onto basically all sort of spend into a single platform, where different users can go ahead and ask questions in natural language via voice. Okay, they can see the dashboard as well over there and analyze that spend, where what is happening, and is there a room of saving opportunity or saving some value over there. They don't need to go ahead and hit that database, see that dashboard, that particular application to get all those analysis and then start working on the negotiation part of it. Okay, so we are bringing the negotiation part, the effort which it takes to start the negotiation. We are at that part of it. We are trying to reduce the time over there. And if you reduce it significantly, what you can do, you can negotiate more. Basically, today, if you want to negotiate with one supplier based on the data silo we have, you will take more time to analyze the spend, then go ahead with the negotiation. But if we reduce that time, that particular negotiation time will be reduced, and you can track more negotiation, or you can target more negotiation with different suppliers. Okay. So with this, if you have not worked on procurement, but yeah, different types of sources we have is ERP system, very famous is the SAP. Then we have market data. Market data is basically commodities data. Okay, you will analyze the commodities. Fluctuation in the prices of commodity can lead to significant change in the prices of your end product or in the prices of your raw material. Okay, so commodity plays a major role. So these are, I have just mentioned three multiple data sources, but ERP and market data sources are major chunk. Okay, which you utilize. And when I say ERP, you will see it's one SAP database. It's not like that. When I say billions of dollars, so you think there will be around thousands of people managing that spend, correct? There will be hundreds or thousands of suppliers which are actually giving you the raw materials. So one person cannot manage these many suppliers. Multiple people are there which are managing these suppliers, purchasing raw material, analyzing those spends, negotiating with those suppliers. Even the raw materials itself are divided into multiple categories to handle. Okay, to handle for the supplier managers to handle that. Okay, the categories are decided based on the use of the raw material. So that part I'm going deep into procurement side. That let's skip it. Let's move towards the technical part of it. So this is the solution architecture which we designed. Okay, we'll start from the left hand side and reach the deployment at the end. Deployment is, I think, the previous Arpit, as mentioned, it's like common everywhere. We have to build CI/CD pipeline if you are building an application, so that the application is not down. There is no downtime. It's continuously running. So deployment part, we will reach towards the end. There is not much to explain over there. What all technologies we are utilizing? We are having Snowflake, okay, for our data warehousing, data cleaning, the ETL stuff. Everything happens in Snowflake. Okay. Now multiple AI agents are involved in this. Few agents are built in Snowflake Cortex. Snowflake provides a service called CLOUDxAI. That's their suite of AI. So if you have not heard, you can go ahead and Google and check it out. CLOUDxAI, it is becoming very popular and it is very advanced. Okay, that's there you can create some agents. Okay, then Google has released its open source framework called Agent Development Kit, ADK. I think this is quietly becoming popular nowadays, and it is almost popular as LangGraph, if people know what LangGraph is, if you guys are working on the AI side. Okay, so Google ADK, we designed our root agent or orchestrator agent there. This agent acts as the center point. When I say center point, it decides what further action needs to be performed based on the context of the question. So the UI is there. Obviously, UI you can build in any application. We have our own internal application. We have built UI on that. User asks a question over there, and it is a free form question, and we are not binding user by anything. Okay, so user can ask it in any form, very short, very long, very descriptive, in any form they can ask. Then it hits the Google ADK, a root or orchestrator agent sitting over there. Now it decides what type of question it is, what sub agents to call. If it has to extract information from database, if it has to extract information from vector database, which is unstructured data, your documents, PDF, Word, PPT, SharePoint, all those files are here. Okay, so it takes up the question, process it thoroughly, then decides whether it needs to call both, it needs to call only one, or whatever it is, or it is not able, it cannot be answered, it is beyond the scope. Everything it handles. Then based on the context of the question, it passes to Snowflake Cortex or the unstructured. So we'll see the Snowflake Cortex first. There, within a Snowflake Cortex, we have two orchestrator agents. Okay, user can either extract information from it or basically write back the information. Okay, writing back is a very dangerous stuff. I'll be honest, because if you allow LLMs or AI to write back something for you, it opens your data for them. Okay, so you cannot definitely write via LLM or AI. You have to create a custom tool which AI can use to perform certain action. Then the data is not open to AI. Okay, and it cannot generate the SQL queries on its own. It has to follow that tool, and tool will be restricted to performing certain actions. So we create our two sub agents over here. Then those are the different sets of data which I just talked about before. Different type of categories holding information on different types of raw materials or maybe market data, all those stuff. I have just mentioned category 1 and category N. There are almost 15, 20 or more than that categories where different type of information is being stored, and each is relevant for different set of people. It's not like all the information is used by only one people or one set of people. It's not like that. So you create semantic views. Cortex has a functionality called semantic views. What you do over there, you create a config file, which is nothing but a YAML file, where you describe your data in plain English language. Okay, when I say plain English language, you will see, oh, this column tells that it holds the part number information. This column holds the supplier information, maybe supplier name, supplier code, whatever you have. That way you describe the data, which acts as the metadata for the LLM to understand which data to select when the user is asking the question. Like that, you will build different semantic views for each category, for each table which you have. Now, this is a one-time job until unless your data schema is changing. If your data schema remains same, data gets refreshed again and again, doesn't matter, that is fine. But let's say you tomorrow add a new column, then only you have to modify this semantic view. Otherwise, it remains as it is. The definition remains as it is. Okay. Now the synonyms or all those stuff which you provide here, whatever description you have given, the metadata piece remains as it is. Okay. Now third, you see the assignment data. This is a separate table which we maintain when we ask user to write back something. They are providing feedback on something, saying the metadata is wrong, saying the pricing information is wrong in the system, or whatever user is entering, it is stored in other table. Then all these tables are linked to each other based on certain keys. Second service is the Cortex search service. How many of you know RAG, retrieval augmented generation? You know, okay, okay. So Cortex search is nothing but a RAG service provided by Snowflake to enhance the performance of Cortex Analyst. So whatever you are seeing semantic views, it is called Cortex Analyst. There is its responsibility is to generate SQL and all, and execute the SQL query, get the value from the database. Cortex Search sits on top of it to enhance its accuracy. Now let's say if I ask you to go ahead, you ask a question, what is the total spend of X? Now what is X? How will you understand? If you are from procurement domain, you might know the name X. Okay, you will understand, yeah, X refers to the supplier, or it refers to the plant, or it refers to a material or part number, whatever it is. How will this agent understand X? It will not understand until unless you put a keyword like supplier X, plant X, vendor X, whatever it is. For it to understand the context or enhance the context of the question, we build search services. Search services are built on top of different columns. Okay, when user asks a question, the moment ADK redirect is to Cortex, all the search services get executed in tandem simultaneously. When I say they are executed, doesn't mean they take seconds of time. Everything is executed within 100 to 200 milliseconds. Okay, each search services, some might take 50, some might take 100, some might take 200 milliseconds. Even if you have 20 to 30 search services, all of them will be executed in 1 to 1.5 seconds. Okay. Now post that, These search services once executed, let's say your X refers to a supplier. So okay, assume that it refers to part number. I have not mentioned it, but there is a search service for supplier also. So that search service will give you the similarity score, saying that yeah, the X refers to the supplier. Based on the confidence score, the analyst will now understand that whatever user is asking about X, X refers to the supplier. Now that data will flow back to the Cortex analyst. It will understand that this is supplier. Now it will start generating the SQL query with all those filtering. It is talking about this supplier. Let's not bring other information. Let's stick to the supplier X information. Post that, we have these custom tools and all. So whenever user asks a question, it enters a Cortex block. The first thing which gets executed after the orchestrator obviously is this, to decide what user is asking. If there are any keywords which analyst is not able to understand on its own, it will go ahead and use search services to decide what user is talking about. Then analyst will run and execute the SQL query to get the output, pass it back to the orchestrator. Orchestrator will start analyzing the data. Okay, the sub agent will start analyzing the data, generate a brief summary for you. Summary can be a slicing and dicing of the data at various angles from various having different metrics like, which I cannot name them, but yeah, different metrics which may be relevant to the stakeholder who is asking the question. So it will generate that response and send it back to the orchestrator. The main root agent, the Google one, and that will display your response on the UI. If the data is unstructured, it will follow the second path, where you will have your unstructured files stored in form of vector databases, stored in chunks within the vector databases. We have used Google services for GCP, Google Cloud Platform, for creating our vector databases and storing our chunks here. Then it will query, retrieve the context, again send it back to the ADK root agent and throw it on the UI. Now, if one of these is not relevant, that will be decided by ADK. Let's say here you have a threshold not meeting, the similarity is not gold, the response is not as per the question asked. It will throw out the response from here. This part, it will only get this and send it back to the user. So that's how the unstructured and the structured piece of information is linked to a root agent, which is basically accessing the whole environment of cost within an organization and getting back you the result. There is no need of going at point 1, 2, 3, 4, getting the data, then analyzing, okay, this is linked to that, that is linked to this. Now I can proceed with the negotiation part. Everything, all data analysis is at your fingertips by asking one question, be it direct, indirect, or any other kind of spend. Okay, whatever spend you have, whatever cost is involved, if you have this, if you have it integrated here in the system, it will answer. The above pipeline is the data pipeline, which is basically getting the raw piece of information, doing some transformation on top of it and putting it in the last block, which are Snowflake views, which on top of which the Cortex analyst semantic views are created. So that's a separate data pipeline, because raw data is, you can say, it's complete. For you, it is a complete garbage. You will not be able to understand it unless you are a procurement expert. So that pipeline runs in parallel. That pipeline is consumed by these agents, which basically gets you the output, and then the root agent transform it as per your requirement and throw it back to you on the UI. Now all this is implemented using only two technologies. Obviously Python I will not consider it as technology now. Okay, so Google ADK is a library, Python library, and it is an open source, released recently. Means last 1 year I will call it recently. Things are changing very fast. Okay, Snowflake Cortex, it's there from like a bit more than 1 year. Both the things are working in sync to get you the final out. Only two things. Yeah, we will move towards the question then. Okay. Custom tools are basically tools, as I told you, cannot ask your LLM to write the data back. Okay, it will create issues. It can delete your data as well if it hallucinates. So that's the tool which you have created, a custom tool which is responsible for writing back your data. And the second one is the RBAC control. As I told, all the information is coming here, and you cannot display every piece of information to every user. It has to be restricted. So we have designed or assigned different roles to each user, and RBAC decides what type of information to present to the user, because the moment user logs in using SSO, their username is captured, and that RBAC comes into picture. If you throw every piece of information to every user, the chances of leakage are very high. Okay. So I think I explained this already. This is nothing but the description of this architecture. How the query ingestion and routing happens. How if the data is, the question reflects the unstructured path, it uses that. If it is a structured path, it goes in that direction. Then it utilizes search and semantic views to query Snowflake views, get all the information. The final one, which I have not explained, is the deployment. Deployment, like any other application, it is based on CI/CD in the Google Kubernetes. Okay, GK engine linked with the container registry where your Docker image resides, and the CI/CD is enabled, linked to GitHub or Bitbucket, wherever you want. The moment you push, CI/CD runs, and your new changes reflect in the application. This is the custom tool which we have created in the Snowflake. This is how you write code in Snowflake. We have created it in a database, given it a name, okay? And then these are the input parameters which we took. When the user says update something, so you cannot just go ahead and write it, correct? Or update some data point. You have to check with user, or you have to check the condition. Along with this, if something else is mandatory to write, you should prompt back user, provide me this information, otherwise I cannot write back the data. It will corrupt the entire information within the system. That should not happen. So it handles everything, all the if-else clauses for writing back to the data. Okay, all the mandatory fields under different scenarios, it will prompt you, provide this if it is missing. So this is the result which we have. When we automated these tasks, I will not say we have covered 100% of the spend. We have covered majority of the spend, okay, in our organization. And if you see, when the user used to analyze it manually, it used to take days, not even hours, and days, can be week, days and all. So what happens is, like, I cannot disclose the exact number. I have transformed into percentage, and that's why you will see the coming as 82, 83, not the some 80, 90 approximate figures. So basically, when you automate these tasks, the case updation, which was writing back, let's say you have 10 write items which you want to write, user has to go and perform 10 times same action. Here, if he calls the tool with the certain set of inputs, done in 2 to 5 minutes. Okay, so you see the case update times is basically reduced by around 83%. Okay, and when I say savings, identification is not like they were not doing it before, but how fast it became. When they were doing it previously and now they were doing it, how fast it has begun to identify the savings opportunity. Now, productivity is 30 to 40%. Basically, when you save time, you put it more towards the negotiation task, correct? Like when you are talking to supplier, you put more effort over there instead of analyzing your data. So the metrics which I have shown is like case assignment. Okay, when you update, let's say you have to update 100 cases. Previously, it used to take around 3 hours, 2 hours, 3 hours, depend upon how much data you want to write. Now it's less than 30 minutes. If it all same values, it will do it not even 30 minutes, can do it in 10 to 15 minutes. Okay, savings opportunity. So let's say for basically 100 cases, you go ahead and analyze savings continuously using the raw data or different projects or different dashboards which are created. Let's talk about dashboards, not even the raw data. It takes 6 to 8 hours or sometimes beyond that, but on an average around 4 to 6 hours, if you have a good dashboard representing all the information, it will take that much time. But it's a manual data gathering process. Okay. Now the case summary, even if you find that the case summary is incomplete in the first shot, you can keep on asking questions, deep diving into the data which you have. It will give you everything. 60 minutes is not something like, yes, it's a concrete 60 minutes, but it's reduced by, you can say, more than 60 to 70% of the time has been reduced. you get information in one shot, done in 5 minutes. You want to deep dive continuously, it might take 1 hour to get the relevant piece of information. Now, task allocation is basically where you are spending your time, analyzing the data or negotiation with the suppliers. And post deploying our assistant, what we have seen in the, basically we captured saving, what user has captured. Once we deployed assistant, we saw there is a 160%, around 165% increase in the amount of value saved. So the time got reduced, the value got increased by automating the task using the AI agents. Now what we are doing next, we are moving more toward the prescriptive strategies. As of now, we have reduced or automated the part where the analysis of data happens. Okay, we have not automated the part where assistant should generate recommendation for them. Okay, arriving till the negotiation part is automated. Generating the adaptive workflows. Basically, let's say the market situation changes, you integrate that, agent will adjust the output accordingly. Okay, will include that information and generate the output accordingly. The predictive analytics, the models are there, but we still have to integrate that. As I told, we reached the part where the analysis is happening. Now we are moving towards the predictive or integrating with the web data where you have all the market trends and everything present. So post this acknowledgement, obviously the leadership, this is basically a research paper, it's not only a talk. So whoever has contributed there, our procurement senior director and different business analyst who has helped us in reaching this goal, and still under development. It's not like we have reached there, but we are in mid of it. Okay, I'll stop here and open it for questions. Yes, you will ask.